present your session.
Thank you. I appreciate the opportunity, and yes, these times with the virus challenges, it's a bit of trouble problem, but at least we can do these over online sessions, which is great, and I hope everyone stays safe and healthy. Okay, right. So let's go on with the slides. Have you got my slides now?
They are on now.
Right.
Yeah.
Okay. Right. So, again, welcome everyone. Thank you for joining this session. And this is the first time I'm talking about this particular topic, so I'm not sure is it going to be longer than what I anticipated or shorter, but we'll see how we go. This is budget versus actual star schema and DAX calculation. I had that as part of my courses and things like that, but haven't spoken that section specifically for a session, and we are going to do that anyway. Who am I? I'm Reza Rad. I'm a consultant and trainer and a coach in Radicad. I'm author of some Power BI books, which one of them, Power BI from Rookie to Rockstar, you can download it from my blog, Radicad website. My contact information is also down below in this slide. You can reach out to me if you have any questions. And that's about it. That's me. Now let's move on to the subject. So I have pretty simple agenda, 3 sections mainly. First, I'll do a quick dimensional modeling 101. What is fact table? What is dimension table? What's star schema? Why it is good and things like that.
Reza,
Could
you put full screen your presentation?
Oh, it is already full screen. Can you see that? Maybe I'll do that one more time from current slide. No?
It's just showing you the app.
Oh, it is not sharing a screen. Okay. I don't know why it wasn't sharing a screen. I'll do share a screen again. Okay.
You just see your PowerPoint.
Start sharing. Yep, I'm doing is sharing now.
Now it's coming up, yeah?
Okay, so let's do some current slide.
It's much better.
Can you see it? Okay, right. Okay, I explained about myself. Agenda. We'll do a quick basic intro of dimensional modeling to get you warmed up for the main course, let's say. Then the main course is star schema of the budget versus actual, how we build that. Then challenges that comes when we have different granularity of the data. ...300 tables, sometimes thousands of tables. You need much simpler layout of the tables to have in the reporting system. And on the other hand side, you want this to perform fast. If you join like out of those 200 tables, 20 of those tables together, merge 20 of them to generate a report, that would be slow. So dimensional modeling is the art that you redesign your tables to make it simpler to work with and also faster to perform. That is called dimensional modeling. Now, for dimensional modeling, you need to have usually two different types of tables, and not all the tables are the same. I mean, they are all tables. They have rows and columns, but they're used for different purposes. Some tables used for x-axis, y-axis, for, let's say, slicer or filters. Some tables are used for values. In your line chart, you have a value, your line, or in column charts, your value. So tables that have values, tables that have slicer items, right? So you need to build a different diagram of these tables. Now, these tables have a name in dimensional modeling. Tables that have that you use for slicer, we call them dimension tables. Dimension tables, and just while I'm talking about, notice as some of these scenarios, because later on we have a quiz, Kahoot quiz questions. So if you answer those, you'll get a prize, 1 month free Academy membership with all the videos in it. Now the thing is that some of those questions is what I'm going to explain in this session, not all of them, but some of them. Okay, so dimension is a slicer table, is a table that you use in x-axis, is a table that you use in y-axis of a chart, a table that you use to describe something. These tables are usually wide. A dimension table can easily have over 100 columns, right? You might not have that much columns, but a dimension table is wide. Too many columns, because more columns you have, more power of analysis you will have. You can slice and dice this by product category, let's say details, color, and anything related to product, right? These tables, however, are not very deep. They are shallow. They don't have too many rows. A dimension with, let's say, 100 million rows probably is not really common. You might have a dimension less than 1 million rows or something like that, even much less than that, right? So dimensions are shallow, but they are wide, very wide. They are descriptive. They explain not happening an action. They actually describe a property. Now, this descriptive information is not always text. They can be let's say number, they can be date, for example, birth date is a date, but still a descriptive field, or age is a number, but still a descriptive field, right? We call these tables dimension tables. Examples of dimension tables are these: customer table, product table, promotion table, things like this. Then we have facts tables. Fact tables are explaining happening of an action. For example, a sales transaction has made. You record that as a entry in a fact table. An inventory movement have been happened. You record that in your fact table. Fact table usually keeps values in it. It doesn't keep descriptive information. In a fact table, I can have things such as order quantity, which is a number, sales amount, profit, costs, things like that. These are numeric, currency value, decimal values, things like this. And the level of details that I store in the fact table is something we call grain of the fact table. So fact table basically is a combination of keys that join this table to the dimension table, like product key, join it to the product table, date key, join it to the date table, customer key, join it to the customer table, and also a set of fields, we call them facts, which are numeric values, sometimes additive, sometimes semi-additive values. And the grain determines what level of details we store. These two tables that you see in this view, one of them storing one record per customer per product, the other one storing one record per customer per date per product, per date per product, and per promotion, per sales territory key. More columns you have in your grain, bigger your table would be. Your fact table is your fact table is usually very easily have millions of rows in a fact table. They don't have so many columns. Fact table might have even less than 10 columns in many cases. Right. Now the relationship between fact table is like this. We have one-to-many relationship between dimension tables to the fact tables. The fact table is sitting in the middle one-to-many relationship from dimension to table to the fact tables, and direction is from dimension to the fact table because you are filtering the values in the fact table. You don't need both directional relationship in this design. It would be single directional. It would be one-to-many. You don't need many-to-many big type of relationship. All plays out really nice. We call this schema, this layout of the tables together, we call that star schema, right? Star schema means fact table in the middle, one single relationship, two dimensions. Fact to dimension, not fact to other fact or fact to or dimension to dimension. That would create another scenario. So star schema is this: fact table, connection to dimension, direct. We won't be doing this type of connection, that dimension connects to another dimension, that dimension to another dimension, that dimension to the fact table. The reason is that you are splitting this up. You are adding extra relationships that are not needed. In this case, product category, subcategory, and product, they can be all combined, flattened in one dimension table. There is no need to have those two tables separately. We can combine them together. This scenario can happen for a lot of things. For example, the category and the product combined together, the color and the product combined together, the customer and customer information combines together, build a customer dimension, right? So you need to flatten your dimension tables most of the cases to achieve this. If you don't do this, if you leave tables like as it is and have dimension to dimension relationship, then you end up with a schema. We call it snowflake schema. Snowflake schema means like dimension to dimension relationship as well. For accessing to a dimension table from a fact table, you probably need to have some intermediate dimension in the middle, which is not ideal. It would perform slower, right? Star schema is not just about one fact table. Some people think that if they have more than one fact table, then it is not a star schema. Actually, this session is about one of those scenarios that we have multiple fact tables, right? But each fact table to the dimensions around would have one single relationship, one direct relationship, right? I always use this metaphor to explain that star schema is like a music conductor in an orchestra. Your orchestra music will still sound something if there is no star schema, if there is no music conductor, but it won't have harmony. It won't be the best music you can get out of those group. If you have the music conductor, or let's say if you have the star schema in your data model, you'll get the best outcome out of that. Okay, so that was a quick 101 of what is the star schema and how it works. Now let's jump into the main course, which is budget versus actual, how we build that model. Now we'll start with the actual model, and then we'll build budgets on top of that, and I'll build that with a Power BI model as we go on. So I'll start from scratch to show you how I built this from beginning. I'll be using a sample database, AdventureWorks. You might have heard of that. It's a very common sample database, SQL Server database that I converted that to Excel version, and I'm using the Excel version of that. Okay, now before I jump into this part, is there any questions already used, or we can just move on?
No question yet.
Okay, sounds good. Right, okay. So I'm going to get data from that Excel file, which is, let's say, that AdventureWorks dataset. That AdventureWorks dataset is about a company that sells bikes and products related to bikes. I have a sales table, and I also have product table, employee table, date table. I'm going to bring them all, sales territory table, right? And you see these dims and facts. these are like, this is a terminology that facts stands for fact table, dim stands for dimension. It's just the naming convention. You might use this or you might have different naming. That doesn't matter. The main thing that matters is how these tables are structured. You see, for example, here, dim sales territory is descriptive information of what these sales territories are, where the sales table is more numeric fields. Okay, so I'll load them all into this Power BI model, and Power BI by default automatically detect the relationship. Sometimes good, not often in this model, because I know there are going to be related based on a specific configuration, so I'll leave that on. But most of the time, it's a good idea to disable it. Okay, so here are my tables. I'm just removing those relationships that are not needed. I have my sales territory table, my product table. I make those a little bit smaller, so you can see that how this is playing out. My employee table, a little bit smaller again, and my date table, which I'm going to connect in a second. So as you can see, this is like that star schema we talked about already. Order date key to the date key, one single relationship between every dimension to the fact table, one too many. Every dimension can filter the fact table, right? Very simple star schema. Now I'm going here and I can build a table visual with some of these information in it. Let's say from date table, I can bring the date. I can change it to be matrix, probably easier. And then from the sales table, I can change this and show the sales amount, right? Now let me make this a little bit bigger in terms of font size so you can easily see what's going on here. Text. This is a way you can increase the font size across everywhere. Okay, here it is. And I can then drill down to the quarters, to the month using this, right? So very simple configuration, and I get the value that I'm looking for. This sales amount is actually, or actual. I'm going to create actually a measure for that. You don't need to, but I'm just going to create a measure for that just to call it actual from now on. So my actual value is basically sum of the sales amount from this table, right? And this actual value is a currency format with 2 decimal values in it. Okay, now I'm going to use that in the values instead of the sales amount, and here you go. Okay, so I managed to have my actuals here, and it works perfectly fine. So the model that we have is already like this, right? It is a star schema model, sales table in the middle, dimensions around. The sales granularity is actually one record per product, per sales territory, per employee, and per day, right? Now, I'm going to add another table, which is my budget table. But the problem is that my budget table is not in the grain of the fact table. It is in a different granularity, because if it was in the same granularity of the fact table, it was easy. I just connected it to all the tables that I need. But this one is quarterly data. So there's a little bit challenge in adding that. Let me add that into my model and show you how things work out. So here, back to the relationship diagram, and from that source again, I'll bring this table, fact sales quota. We consider that to be our budget, let's say. Loading that. This would automatically detect one of the relationships. Fact sales quota has a relationship with dim employee, which is fine. Okay. But it doesn't have any relationship with any date and things like that. Why? Because I see here that we have a calendar quarter and a calendar year, right? So this is a quarterly data. Let me show you how the data looks like here in the data tab. here it is. I'm making it a little bit bigger. We have one record per quarter and per employee, of course, right? But we don't have monthly or daily information. And when we don't have a daily information, what we are going to do? Are we going to, let's say, connect it to a different dimension? So there are two approaches usually here. One approach is I can create a summarized version of my date table. I can call it quarter table. Call it quarter dimension, connect this to that, and then quarter dimension to the date dimension, because they also need to work with each other. But then I have dimension to dimension relationship, which would be going towards Snowflake scenario. And then what if I have later on another table which is on a monthly basis, another table which is on a weekly basis? Am I going to create a dimension for each of those? No, that's not the ideal way. So what I can do is instead bring this relationship to the date table. And how can I do that? I can connect this to the first date of every quarter or the last day of every quarter, depends on which one you prefer. Let's say I do it first day of the quarter. And I can do that here in Power Query. Now, this is not a course about Power Query. I'm just going through that part really fast just to show you that such a thing is possible. To fetch the month number from the quarter, I can do this transformation. I can add a column, custom column, and I can say this custom column is my month value, which is whatever this quarter is, -1. By 3, the end result +1. This expression can give me the month from the quarter, or you can use DAX expressions for that. I'm just using the Power Query for this here. Now I'm going to add a prefix for these. For those that are 7, I'm making it 07. For those that are 1, making it 01, which I can do that with transforming this. Under format, add a prefix 0. So you can see that this is added prefix, but sometimes it's 3 characters. So out of this, I can extract only the last 2 characters. As you can realize, I made my month field here to be 2 characters length. Now, calendar year and month, I combine them together with merge. And I'm calling it date key. Okay, that's my date key. It has the year and the month, and then at the end I just add a 01 to saying that this is, let's say, the first day of that particular month. So this is my date key as a result, and I'm making this a numeric field. Now, I went through this process a little bit fast because this process, I mean, getting the date key from quarter or from month values or things like that can be different. You might do that in SQL Server, you might do that in DAX, you might do that in Power Query. Your data might be different, you might have month name, so everything might be different, right? So this part, how you are going to do that is not the most important part of this session. Doing this is the most important part of this work, right? So I ended up with having a date key from a scenario that I had that I had only year and quarter. Now I have the date key, which is always the first day of every quarter when you look at it. 1st of July or 1st of October or 1st of January. But that's enough for me to connect to my date table, because date table also have that that kind of connection. Sometimes you just use date field itself. Sometimes you use a date key, which is 4 digits year, for 2 digits month, 2 digits day. That is what I used here. But you can also use the date field itself. Okay, so close and apply. And this time now I have this, it should automatically create the connection. And here you go. You see the connection is created between these tables. So here I have also my star schema, right? So my star schema from here, consider this the heart of star with not 5 points with 4 points, 4 dimensions. The other one is also with 2 dimensions, right? So each fact table represents a star schema. And I can easily use these to analyze data. I can come here in my relationship diagram, in my visual here, and bring something from the sales quota, which I'm going to call it budget. So same thing, I'm going to create a measure here. These are just very simple measures, simply just sum of something. I'm going to call this budget. And my budget value is sum of the sales quota, sales amount quota, which this one is going to be also a currency value with 2 decimal places. Right. So doing this, now I have the budget and the actual beside each other, right? Without any reason for creating an extra dimension in the middle, making one relationship like both directional or things like that. Everything works perfectly fine. I can go to the year level, I can go down to the quarter level. It just works perfectly fine. I can have another table visual here. In this table visual, I can have this information by employee. Let's say, for example, the first name of employee, last name, because this is also one of the shared dimensions, and then the actual and the budget. Some people prefer to keep all their measures in one table, call it measure table. Some people, like me, prefer it to be in a different tables based on their relationship to those tables. That is just the standard you like to use. Here you see I have for every person the actual versus budget and things like that, and it works perfectly fine, right? There is no need for me to create any both directional relationship, no need for me to do anything special to get this working. This is just working by itself like that, right? So back to my slides. The solution for bringing budget to here was connecting my budget table to the date table, and for that I created the date key. This date key could be the first day of the quarter, the last day of the quarter. This is the decision you make. This is the standard that you define. Whatever standard you define, go ahead with that. Create that date key. By all means, you are skilled at, from DAX expressions as a calculated column in Power Query, like the way that I did it in SQL from your select statement or something like that. That doesn't matter. The main thing is that you create that field that you can then link to the date dimension. And then this creates a budget and budget versus actual a full star schema design. Even they are 2 different tables, each of those is representing a star model in itself, right? So now comes the other challenge. What if I want to, and these are measures that I just can create. Oh, I haven't created budget versus actual. Let me show you that as well before we get to the question points. So I can do this measure. I can say, again, very simple measures in this scenario. I can say my budget versus actual is basically budget minus actual, right? Very simple calculation. So this would be the variance, the budget versus actual. I can bring it here. It shows me how much of the budget we are or something like that. And I can also do a percentage. So that would be another measure. I can say this one is budget versus actual percentage, and that would be basically a divide of actual versus budget. Usually using divide is better than using the operator divide if you are not sure what is the value you are dividing by, because if you expect divide by 0 to happen, this would take care of that. Here it is, and I make this one a percentage format, Here it is. And that one should be currency, but let's leave it here. Okay, so everything works fine. I have budget, actual, budget versus actual, and the percentage of that. And I can start sorting by any of these if I want to. So everything plays very nice. But what is the problem? The problem is when I want to go one level down. Look at here. If I go one level down, this is year. I'll start from here. In year level, everything is fine. In quarter level, everything is fine. But if I go to the month level, you see that at some month, I don't have any budget. My budget versus actual is negative, and there is no percentage. Why is that? Because I have the budget value only at quarter level, and I see those at the quarter level because they only exist in a quarter level. I don't have a monthly budget. Now, some businesses say, yeah, budget is at quarter level. We don't really want anyone to go down to the month level. So if they go to month level, yeah, we don't have budget information. So this is not correct anyway, right? We are not going to fix it because budget is at quarter level. Some people say when you go to the month level, I can divide this by the number of months and get you the monthly level budget. Even it is not really designed for a monthly scenario, but it can explain it that way, right? So I'm going to explain that in the next part, which is how we are going to use some DAX expression to calculate this. Now, before talking about that, let's check if there is any other questions. Any questions? Just?
Yeah, I think there's a question around techniques regarding rolling forecasts.
Right. Okay. I'd say not that much related to this topic itself, but for any rolling calculation, you basically need to find your rolling period. Let's say you are looking at March 2016 and you want to look at your rolling 12 months back. So from March 2006, let's say. From March 2006, you go all the way to April 2005, or let's say from April 2005 all the way to the March, which gives you a rolling 12-month period, and calculate all the values in between. You can use functions such as dates between, such as dates in period to give you that period, combined with date add or same period last year that give you the last year. If you want a rolling period of 6 months, you can use date add minus 6 months and things like that. That will give you that rolling period and calculate that result.
Okay, thank you. And then we have another question around, can you explain the scenario for Snowflake? How do we know when we should use Snowflake or star schema?
I'd say don't use Snowflake, and let me explain one thing here, because a lot of miscommunication here. Snowflake as a schema is what I'm talking about, not Snowflake as a database technology. You know that there's a database technology, there's a company called Snowflake. That is totally separate. That is a cloud-based database technology, something like Azure SQL database, a Snowflake database, right? Totally different database technologies. They just named it Snowflake, right? That doesn't mean that if you use them, you are using a Snowflake schema. No, a Snowflake as a schema means that whenever you have a like dimension to dimension relationship, your fact table is not in a direct contact with your fact table. Like this is a Snowflake model. You can see that this dimension is connected to that dimension is connected to that, and that is connected to this fact table. Why it is a Snowflake and why it is not great to have it? Because I need two extra relationships here. If I wanted to design it in a star schema way, I combine these three tables, product subcategory, and product category, into one, and had one single relationship to the fact table. You might think, okay, if we combine those three tables, we are adding a lot of redundant values, like product category would be repeated in many of these rows here, which is absolutely fine. When you are designing a star schema, you shouldn't be thinking about you are making a lot of redundant values available. No, that's not what you should be thinking about. You should be thinking about how to make it simpler to analyze how to make it faster. When I have these all combined in one table, this would be much faster to slice and dice. I have just one relationship. I will have extra columns, which is absolutely fine. Your dimension table can have hundreds of columns.
Thank you for, I think that's the question for now.
Right. Okay, nice. So let's go back to my example. So what about lower granularity? What if I have my budget in a quarterly level, but in fact, I want actually this to show on a monthly level, even if budget is not designed in a monthly level. When I go to the monthly level, because my actual is in that level, I still want to be able to get a good comparison, budget versus actual, and that would be fair comparison to have, because otherwise, for example, for August, for September, it doesn't show me anything. So how can I do that? You might think, well, we have quarterly data, we can divide that by 3, we get monthly data, right? So you might think something like this. Let's say you might think that my monthly budget is the quarterly budget, or let's say the actual budget itself, divided by 3, right? Now, the thing is that this won't work. Let me bring it up and you'll see how. You see that this works for the first month of each quarter, but only for the first month. For example, here for Q3 of 2005, I have that value only calculated correctly for July, but then August and September, nothing. Now, the reason for that is that when I am in the August, right, when I'm looking at the August as the context of my filter here, every field that you use as a slice and dice here is the context of your filter, right? So the filter context here is August. When I'm in August, there is no quarterly data at August. Quarterly data is only connected to the first of each quarter, to the first month of each quarter. That is why I have it at July. Now, if I assign my quarterly data to the last month of each quarter, I had it for September. But still, my August would be always blank, or the other months that I didn't assign would be always blank. So how can I do that? I can do it a little bit differently. I can say, instead of calculating monthly budget like this, I can first find out what date we are, the context of the current date, and based on that, I can calculate the sales of the first quarter, of the first of that quarter. Right. So if I want to do monthly quota or monthly budget, I can do it this way. I can say, okay, I'm defining a variable. I mean, variable is not necessary, but I just make it here to make it a little bit easier to understand. Let's say, okay, this variable is which quarter, and I'm getting the last date of the full date alternate key here. Know which date we are. So this is saying to me that, for example, when I'm in August, this would be a value in August. Now, from that value, I get first of quarter of that value, which would be first start of quarter, I guess. Start of quarter, yeah. Start of quarter of that variable. So what I'm doing here, first, finding out what is the date of the current record. This simple expression will give you the date of the current record. We don't have a DAX expression saying that give me the date of the current record. We don't have that. You can use selected value, you can use last date, you can use first date, things like this, right? So I used last date. And then that gives me, let's say, for example, somewhere in August. From there, I'll find the start of that quarter. Let's say if it was August, the start of that quarter, which would be 1st of July. And then I say, okay, now that we know what is the start of the quarter, calculate the budget value for 1st of the quarter. 1st of quarter. I probably wrote it wrong. Okay, let me just copy that expression that I have, because that would make it much simpler. Instead of typing, we don't have any much time to type it anyway as well. Okay, so here is my expression. Did I miss the measure name? Yep. Okay, let's call the measure name monthly budget equal. Okay, and here it is. Okay, right. So it is the same thing. Here I just use that budget measure, which is still fine. So I'm calculating that for the first date of the quarter and then dividing it by 3. Remember, because if I don't do that, this would give me the whole quarter value for each month. I'm dividing it by 3. As a result, this gives me this value. So I'll bring it just beside this so that you can see how it is. What did I call this measure? I think I called it monthly budget. Yeah, it is a monthly budget. Okay, now it should show me the result. Why it is not doing that? I think the reason is that I'm using the default and not using the actual date table. So here it is. You can see it is working. That was the problem of actual date table. So I'm going to bring this down, bring my other Power BI model, because that will show you a little bit easier how this is going to work. So back to my monthly quota. So here it is, my monthly quota. I'm calculating first day of each quarter. The difference in this model and that model was that model was using the default date dimension. This is using the custom date dimension. So I try to stick into custom date dimension, don't make it confusing. And here it is, the same expression. And as a result, if I bring it to the monthly level data, or even here, okay, let me bring that monthly level where we are with that monthly value. Yep, monthly quota. Okay, and then I can also bring the month number of the year, or English month name is fine, but let me bring the month number of the year into this visual. Now here you can see that for each month I have this value. And because I have this value, then I can calculate budget versus actual considering this value, which gives me the correct result rather than comparing it with the normal budget, which was basically quarterly budget, right? Okay, so back to my monthly quota, or monthly budget. So this is calculating it on a monthly level. What if I go, let's say, one level down into daily level? Let's say I want to go to daily level, but still I want this calculation to happen, right? Something similar to this, but a little bit different. I'm not going to write it again. I'm just going to show you this as example. So here is an example of daily quota or daily budget, which is the same thing. At the beginning, I start with finding which quarter we are, which date it is, finding the start of that quarter. Now for daily quota or daily budget, what I've done, in addition to finding the start of quarter, I also found end of the quarter. And then find the difference between the start and end. Let's say this quarter is 90 days, it is 91 days, it is, let's say, 92 days, whatever it is. So that is days in quarter. And then finally, when I calculate the sales of that quarter, I divide it by the number of days in that quarter. So let's say this is like $1 million, whatever it is, divided by 90 days, 91 days, that will give me daily budget, right? So I divide that to achieve the lower granularity. Using these type of DAX expression, I calculate the budget at the level that is having the budget data from the filter context of my value, right? You can download all of these expressions from links that I provide at the end as well, right? Now, here comes another interesting part, that what if I want this to be for a weekly scenario, right? This is daily budget. What if I want this to be weekly budget? You may say, okay, I will calculate daily and then we divide it by 7, that would become weekly, right? That can be true, but what if your period of week is like sitting halfway in between the end of quarter for 1 week and start of quarter in another week, right? Something like this. Let me show you in my calendar over here, right? So April is the start of a quarter, but what if I'm looking at a week that starts from Monday 30th of March to Sunday 5th of April? Part of this is in one quarter, part of this is another quarter, right? And if I'm going to do that, then the problem is that my daily calculation would be either in based on the April or March. How can I get the daily budget for each of these correct and at the end sum them up together? The main thing is that you have to do that daily for each value separately and then sum them up together to get your weekly or even any custom period, right? This can be a week, this can be 2 weeks, this can be 20 days, whatever, right? You have to calculate it for every single day, right? And that is what I did with this expression. Okay, a little bit longer expression, but I'll explain how this works. So we call it, let's say, custom period budget. And this is something that works regardless of the level of details you have, right? So you can easily use this instead of all of those expressions that you have seen. I just build it all the way up to bring it to this level, right? So I first get the current date. Based on that, I get the start and end of the quarter. I get also the end date as well. Then from start to end date of that period I'm looking at, I'll create a virtual table using dates between. From this start date to end date, let's get back to my example here, from 30th of April to 5th of 30th of March to 5th of April. That would give me a table of dates. In that table of dates, I add a column, and in that column, I add the daily quota or the daily budget for every one of those. I calculate the daily. Then out of that, I calculate sum of that daily budget, right? So I created a virtual table. Using this virtual table, I calculated for every single 1 day, then sum them up all together. The reason I did it was that because if I wanted to calculate all of them at once, it would have given me a wrong result, because it would have calculated either on this quarter, which is the first quarter, or let's say the April quarter to June, or it would have been January to March, right? So I split it. You can split it in two, though, to make it a little bit smaller virtual table, in a way that you get whatever start period is only to the end of that quarter, and then from the start of the next quarter to the end period, things like that. You need to find out how many quarters you have. That would make this virtual table smaller, but even this calculation works just fine, right? So this means that if I use this calculation, it would work perfectly fine in all levels of analysis that I have. Let me bring it here. For example, this is an example. Yep, here it is. Making it a little bit smaller. So this works at quarterly information. If I bring the month itself, let me bring the visualization, and month number of year comes here. It works just fine at the monthly level as well. I can bring even the day. And the funny thing here is that my actual is not actually daily. My actual is monthly. If I had my actual daily, it would have even shown me that value for the actual. But here you can see that my budget is working just fine. My actual, if I had it here, wouldn't, right? So, and sorry, this is showing my count of the days. It should be showing me just the day itself. Don't summarize. Here it is. Okay. Right. So let me remove that. Going back to the quarter. So I'll bring that expression one more time. So the whole thing about this expression is that I use a virtual table. One of the methods you can use in DAX expression is to use a virtual table to iterate over some calculation. And I use the iterator here, SumX. SumX is an iterator expression that I use to iterate through this virtual table, calculate the daily value for each, and then finally summarize it. Right. Okay, so back to my slide. Do we have any other questions before I wrap it up? Yes.
Yeah. Actually, we have a question from Eric. Couldn't you do this in M?
We can definitely. Now that's a very good question. Now, if I'm really going to the daily level of this, it is probably definitely better to do it in M, in Power Query, in the back end. I mean, in SQL Server, some of you might be more familiar with that, because that way I've done all of these pre-calculations, right? If I'm really going to the level of, let's say, day or something like that. But if I'm not going to that level, if, for example, I might go just one level down, which is monthly level, it's not a still daily level, things like this might not be needed to be done in M level, still DAX would be fast calculation, then this would be just fine. And doing it this way means that my other dimensions would still slice and dice. I can get employee over that month and things like that, which would be working fine. But doing it in M, doing it in backend design is definitely a good idea if I'm going to very low level of the details to look at everyday budget and things like that.
Thanks. And then I have a question. If you can share the PBIX file.
I will send you my slide. In the slide, let me bring it as well. Good time to explain. In the slide, I have links to all of my blog articles. I actually have blog articles about these subjects I talked about, and much more information in those as well. Two of them. One is budget versus actual zero complexity model, which is talking about the star schema design. Another is budget versus actual, talking about these calculations and DAX expressions that I explained to you. And from there, you can download files, codes, everything you want.
Perfect, thank you.
And it has also some other information, such as what if you want to build the inventory model in Power BI, other design patterns in Power BI. So make sure you check this last slide specifically.
Perfect, thank you.
Perfect.
Welcome. Okay, no more questions on that side?
No, just go on.
No.
Okay, right. So, so to wrap up, this was a session about showing you first what is a star schema, how you can use it in a model, in a real world scenario. We have like event tables with different granularity. One of them was at daily level, another was quarterly level, but we still managed to build a star schema to work with that. You also learned some back-end Power Query tricks to achieve a date key and combine it together with the date dimension, and also some DAX expression to come and help at the end to calculate the monthly level budget versus actual, or even daily level, or even any custom period, right? this is like an example of one of the design patterns in the world of Power BI. Every design pattern is talking about a specific real-world problem solving. Another design pattern can be how to build the inventory model. Again, it has some star schema design, M scripting, Power Query, and some DAX expression. So combination of these build a design pattern, which I highly recommend you to go and check it out, how these are working. And the main thing is that you should be using the right tool for doing the right thing. For example, for creating that date key, Power Query is definitely a good tool to use rather than DAX. For some of the calculations, DAX might be better to use than Power Query. The main thing is that you use the combination of these tools to achieve the data model. I have some Power BI courses through our academy, which you can go and watch it. Now we have a quiz that one of you, the lucky winner, will get the 1 month access to the Rad Academy. We have more than 11 courses already there, Power BI and AI. If you are looking for free resources, these blog posts are all free. I have YouTube videos which you can go and watch it at your own time.